Okay, we're on lesson 21 of module 4. In this lesson, we are going to continue writing equations of a line. And in the past lesson, in lesson 20, we used the slope-intercept form and we knew the y-intercept and we could calculate the slope, and from that we could write the equation. In this lesson, we're going to get a little more general. We're going to be able to write an equation if all we know is any 2 points on the line, or if we know the slope and a point on the line. So we're also going to look at a different form of the slope formula. So let's get going with example 1. So looking at example 1, we're asked to recognize that this is a line in the coordinate plane. What linear equation would be the graph of line L? So we were asked to do that before, but we relied on knowing the y-intercept. And in this case, the y-intercept crosses the graph in between grid lines. So it's not a good point for us, so we're not going to be able to use it. So what we need to do is locate two points that we can read the coordinates of, and I see one right here, and I see another one up here. Okay, so let's record the coordinates of those points. So we have the point 5, 4, and we have the point -2, 2. So we have those 2 points, and so what we want to do is start by finding the slope. So we're going to find the slope of this line. So I can find the slope a couple different ways. I'm going to think of slope as the difference in the y-coordinates, which should be this distance right here. So the difference in the y-coordinates would be 4 minus 2. And then the difference in the x-coordinates is right here, 4 minus 2, so this would be 5 minus a -2. And so that simplifies to 2 7ths. And it checks out that this is a positive slope because that line is upwards leaning. If I'm going from right to left, it's heading up. So that slope is the rise over the run, so 2 over 7. Okay, so if I knew the y-intercept, I would just put it right into y equals mx plus b. But I don't know the y-intercept. I don't know this number right here. But I do know the slope. I know this. And I do have a couple points on the plane. That are solution to this equation. So I'm going to write what I know, that y is equal to 2 7ths x plus b. And I can substitute, and I'm just going to go ahead and use an eraser here. I can substitute an xy pair in there. So I'm going to substitute the -2, 2. So the y goes here, so this is y. 2 7ths x, x is -2 plus b. So now I have an equation where all I need to do is solve for b. So I've got 2 is equal to -4 7ths plus b. Add 4 7ths to both sides, and I get 2 and 4 7ths equals b. And I'm going to write this fraction as an improper fraction because we don't want to put a mixed number in an equation like this. So this would be 18 7ths. Let's look at the graph and see if that kind of checks out, and it does. The place where this crosses the y-axis is between 2 and 3. It looks like it's a little bit more than 2.5. So this so we must have done our computation correctly to find this b. It's not exactly 2.5, but it's a little more than 2.5. So the equation of this line then would be, putting all the parts we know, y is equal to 2/7 x plus 18/7. Okay, let's look at this a little bit more. So what if we had used the other point on the line? The other point on the line was 5, 4, had coordinates 5, 4. So if we substitute those in for x and y, the y is 4. 4 equals 2/7 times x, which is 5, plus b. Okay, so what we want to see is if we're going to come up with the same number for b. So we get 4 is equal to 10/7 plus b. And so if I subtract 10/7 from both sides, then on the right side I end up just with b. And over here, 4 is equal to how many sevens? Well, it's 28, right? So 28 minus 10, so this would be, we'll just write it out, 28/7 minus 10/7, or plus a negative 10/7 is b. So b is equal to 18/7, which is exactly the result we got putting in the other point, which was a point on this, the graph of this line, which was -2, 2. So it doesn't matter which point we put in because we knew they were on the same line to start, and so they both would be solutions to the same equation. Okay, so there's one more thing that we can do with this equation once we have it. And that's that you might need to find this equation, put this equation in standard form. And remember, standard form is ax plus by equals c. And you got a lot of practice doing that in the last lesson. And the thing is that a, b, and c are integers. So there's no fractions allowed. And a, the first number out here, the leading coefficient, has to be non-negative. Okay, so what we're going to do is, just pick another color. We're going to multiply through by something to get rid of the fraction. So that would be a 7. So we're going to do 7 times y on this side is equal to 7 times 2/7 x plus 18/7. And so multiplying that out, we get 7y is equal to, now 7 times 2/7 x is just 2x. 7 times 18/7 is 18. So this is plus 18. So we're getting close. Now we need to subtract 2x. We want to get the x and y terms on the same side. So let's subtract 2x from both sides. And then we end up with a negative 2x plus 7y is equal to 18. And then because that leading coefficient is negative, I'm going to multiply the whole thing through by -1. Okay, so multiply both sides of the equation by -1, and that would give me the opposite of every term. 2x minus 7y is equal to -18. So that's that same equation in standard form. These will graph the exact same line. Okay, let's do another one. So let L be the line in the coordinate plane that's shown. What linear equation is the graph of line L? So we should be able to find an equation for this line. And once again, I'm going to start by locating those nice points that will allow me to see the coordinates. And I see one there, and hopefully you're looking for the next one. It's right down here. So let's write the coordinates of those points. We've got 4, 1, and we've got the point -1, 4. Okay, so we always need to find the slope. That's always going to be one of the first steps when you're doing this, unless you're already given the slope. So the slope is going to be the difference in the y, so 4 minus 1, divided by the difference in the x. Wait a minute, I have this, that's a -1 right there. 4 minus 1 divided by the difference in the x, which would be -1 minus this 4 right here. So it's going to be -1 minus 4. All right, so that is 4 minus 1 is 3. -1 minus -4 is negative, so I'm going to put the negative sign out front here, -5. So -3/5 is our slope. So our starting point is y is equal to -3/5 x plus some number, and I don't know what it is, except that I do know that it's between 3 and 4 right here. Crosses the y-axis between 3 and 4. So we can find that number b by plugging in one of our known points. And let's go with a positive one down here. We'll put in 4, 1. So the y value is 1. So I'm going to say 1 is equal to -3/5 times the x value, which is 4, plus b. Okay, so 1 is equal to -12/5 plus b. Okay, so to get rid of the 12/5 on the right-hand side of the equation and solve for b, I need to add it. So let's use some green so I'm going to add 12/5, add 12/5, and this becomes 5/5 plus 12/5 is 17/5. And then on the other side of the equation, I just have b. So b is equal to 17/5. Okay, so 17/5 is 3 2/5. So that makes sense with our graph. 3 2/5 right there, a little less than 3 1/2. Okay, so the equation of this line would be y is equal to -3/5 x plus 17/5. And that is the slope-intercept form of that line. So let's put that in standard form now. Okay, so here's our equation, and we want to just multiply this entire equation by 5, right? We want to multiply by 5 so we can get rid of the fractions, get rid of those denominators. So let's look at what we have. 5 times y is 5y. 5 times negative 3/5 is negative 3x. And 5 times 17/5 is 17. So I've multiplied every term through by 5 to get an equivalent equation. Now I'm going to add, I'm going to add 3x to both sides of that equation. And then I'm left with 3x plus 5y is equal to 17. The negative 3x and the positive 3x become 0 together. So this is our equation. 3x plus 5y equals 17. And that's equivalent to the slope-intercept form that we had up above there. Okay, so let's look at example 3. We're shown the x-axis and part of the x-axis. The origin is not part of this little snippet of the graph, but this is a line in the coordinate plane. There is a y-axis over there, and we're going to assume that the scale on that y-axis is 1. So each one of it's the same scale as the x-axis, which isn't always true. So you always need to be careful to read the scale on both the x and y-axis. Okay, so we certainly don't know the y-intercept here. We can't even see where it crosses the graph. So once again, we're looking for those nice points where the line crosses grid lines. So go ahead and look for those. Okay, so I've got them, and I've got the coordinates here at 12, 2, and over here at 13, 7. 13, 7 are the coordinates of the other point. So I haven't been drawing these slope triangles, but here's the one for this graph. The horizontal distance is 1, so we can read the slope right here. 2, 3, 4, 5 is 5. So the slope of this line should be 5, but let's do it with the formula again. You don't always want to have to graph the points to find the slope, so it's nice to be practiced in doing it with the formula. So the difference in y's is 7 minus 2. The difference in x then would be 13 minus 12. And so my slope is 7 minus 2 is 5. 13 minus 12 is 1. 5 over 1 is just 5. Okay, so we've got a slope of 5. We found it 2 different ways. All right, so now we need to use the slope equation. So I know that this line, the equation of this line can be written in the format of the slope-intercept form. The only problem is I don't know the y-intercept. So we don't know b, so we're solving for it. We're going to solve for it by using one of the points. I'm going to use the points with the smaller numbers because that usually works out better for me. So we're going to use this point right here, 2, 12. So the y-coordinate is 2. The x-coordinate is 12. And that's going to help us find b. So we know this is a solution to the equation, so we can plug in the points, making that a true statement. So 2 is equal to 5 times 12 is 60 plus b. Now I want to subtract 60 from both sides. subtract 60, and end up with b on the right side of the equation. 2 minus 60 is the same as 2 plus negative 60. So this is going to be negative 58. So my y-intercept is negative 58. So if you think about it, if you think of the steepness of this line, it's heading down towards the y-axis, but it's going to take a while for it to actually get there because of how steep this line is. If it was less steep, it would get to the y-axis sooner. But it's going to take a long time. In fact, it's going to cross the y-axis at negative 58. So the equation of this line, for example, 3, is y is equal to the slope times x, 5x, plus negative 58, which we can write just as minus 58. So there's the equation of that line. Once again, we're going to go ahead and practice putting this in standard form. This time, and I'll write it over here, ax plus by equals c. So that means we need an x term, then a y term, and then a constant term. Okay, so we've got our y term, our x term, and our constant term. We just need to rearrange them. No fractions, so there's no need to multiply through by anything. So you can pause and practice this on your own. And I'm just going to go ahead so you can come back and check your solution. Okay, so I'm going to subtract 5x from both sides of this equation. Minus 5x. Okay, and then we'll write the result here. So on the left, we've got negative 5x plus y. And on the right, we just have negative 58. Okay, so what we want to do now is get rid of that negative on the x term. We don't want a negative out front. And there's a way to handle that. And the way to handle that is just to multiply all the way through by negative 1, because negative 1 just takes the opposite of everything. So if I do it to one side, I have to do it to the other. So I'm multiplying every term by negative 1. So negative 1 times negative 5x is 5x. Negative 1 times y is minus y is equal to the opposite of negative 58, which is 58. So there's our equation in standard form. 5x minus y equals 58. Okay, let's look at example 4. We want to find the linear equation that describes the graph of line L. And yeah, so we want to do that. So this line is actually going through a lot of nice points. So let's look at a couple of them right here, right here. This graph actually goes through the origin, and then here's another one here. So let's look at what that slope would be. We've got the point, whoops, we've got the point 0, 0. And we've got another point up here, which is 3, 1. Okay, so what is the slope of this line? Well, let's draw our slope triangle. We got over 3 and up 1. Okay, so looks like it should be 1/3. So the slope, we can calculate it as well. Slope would be the difference in the y's, which would be 1 minus 0, over the difference in the x, which is 3 minus 0. So this is clearly 1/3. Okay, so we actually can go directly to y-intercept form for this one. And the reason being is that in this equation we know the y-intercept equals 0. Y-intercept is 0. So we've got y is equal to m, which is 1/3 x, plus b, which is 0. Okay, so we would write this equation just as y equals 1/3 x. So when an equation is in this form, just y equals mx, y equals some number times x, that's a special type of relationship that you might recognize. This is a proportional relationship where one number, the ratios are always equal of y to x. If I take, so I'm just taking any number times it, not any number, I'm taking this constant of proportionality. This is the constant here that keeps these two numbers x and y in proportion. So anyway, this is a proportional relationship, and it's a constant rate, right? Because we've got this slope, this constant slope going on, and slope is our rate of change. So anytime an equation passes through the origin, the value for b is going to be 0. So you're going to have this type of relationship where y equals some number times x, just mx, and b is 0. Okay, enough said about that. Okay, so I'd like you to find a clean place in your notes, and we've already been using the slope formula. We've defined it, we've proved what it is, we've shown that it's well defined, that it's the same anywhere on the line. But when you look in other books for slope, you're going to find a little bit different notation. So generally, points on a line are given this type of notation. So we've got x1, y1 would be 1 point that might lie on the line, and x2, y2 could be another point. So we're going to say that these 2 points, x1, y1, and x2, y2, are points on the graph of a line, and I could find their slope. Their slope would be what? See if you can write the slope formula given that notation for those points there. Okay, so we know that slope is the difference in the y. So I'll start with the second point, y2 minus y1, divided by the difference in the x, or the horizontal difference. This would be x2 minus x1. So this is the more generally recognized slope formula with that notation, but it's exactly the same as what we have been using. Okay, so there's another form for a linear equation, and it's called the point slope form. Okay, so we've had slope intercept form where we could find the slope and the y-intercept really easily. We've had standard form, which is nice in its own right. It makes the equation look somewhat simpler without having all those fractions on it. And then we have something called point slope form, and this is useful if you have a point and the slope. You can plug it into this equation. So point slope form just relies on rearranging the slope equation right here. So I'm going to take the slope equation and multiply both sides of it by this quantity, x2 minus x1, and over here, x2 minus x1. And so what do we end up with? We end up with, on the left, I'm going to take the m out to the front of the parentheses. So I have m times x2 minus x1 is equal to y2 minus y1. Okay, so now we're getting close to point slope form, but x1, y1, x2, y2, those are points on the line. So they're numbers that we know. But what I want to do now is I want to replace one of those with variables. So these could stand for any number that would be a solution to the equation. So we can put in x minus x1 and y minus y1. So m times x minus x1 equals y minus y1. So if I have the slope right here, and I have any point, x1, y1, I can plug those two things into this equation, simplify it, and get the equation for the line with that slope passing through that point, x1, y1. Okay, so we'll do an example of that on one of these exercises just to show you how that works. And you remember, I'll go ahead and write the slope-intercept form, which is y equals mx plus b, where m is the slope and b is the y-intercept. Okay, so that's just kind of a summary of what we've been working with in these last few lessons. Okay, so now find exercise 1, and you can start working through these exercises. There are 5 of them. You can work on them independently, just coming back to the video or going to the teacher's edition to check your work. Okay, so we're going to look at exercises 1 through 5, and each one of them is going to give us a little something different to talk about. Okay, so here is the slope calculation for the line in exercise 1. Found 2 points at 5, -1 and at 2, -2 that are on the line. I use those to find the slope, and I can also verify the slope by drawing a slope triangle here and showing that this would be 1/3 or 1/3. Okay, so now that we have the slope, we can put it in the slope-intercept form. As much as we know, we don't know that slope-intercept. We know it's somewhere between -2 and -3. Okay, so we do have a couple of known points. So let's use 2, -2. So the y-coordinate is going to substitute in for y. So that'd be -2 is equal to 1/3 times 2, the x-coordinate, plus b. So we've got -2 is equal to 2/3 plus b. Subtracting 2/3, we get that when we subtract 2/3 from both sides to get b by itself. I'm going to rewrite -2 as thirds. So I want, let's get my eraser. So let's get rid of that. And that's a -2. So 2 would be 6/3. thirds. Maybe negative 6 thirds. So now I can combine these two quantities here, these two fractions. I've got negative 6 minus 2 over 3, so that's negative 8 thirds, and that's equal to B, because 2 thirds minus 2 thirds is 0. So I got negative 8 thirds is equal to B. And so I'm ready to write the equation of my line. So the equation of my line is y is equal to the slope, which is 1/3, times x, plus b, which is minus 8 thirds. So let's look at the value of that. That's negative 2 and 2 thirds. So that jives with our graph right here, because the y-intercept should be between 2 and 3, a little bit closer to 3. So negative 8 thirds. So there is our equation for that line. And we're done. We're not asked this time to put it in standard form, so we're not going to. Okay, so write the equation for the line in this figure. So if you haven't done it yet, go ahead and pause and then come back and we'll work through the solution together. Okay, so here's these are the points I found, and here's my slope calculation. So we get the difference in y is 8 minus 7, which is 1, and the difference in x is 2 minus a negative 3, which becomes 2 plus 3, or 5. So the slope of this line is 1/5. So now I can just write the equation as I know it, as much as I know 1/5 times x, because that's the slope times x, plus some number b. Okay, and we can see that the y-intercept should be between 7 and 8 there. So let's see what we get here. So we're going to put in one of our points. Let's use 2, 8. You could use either one. Remember we did that earlier where we put a different point in and got the same equation. So my coordinates are 8 and 2 for the x and the y. So this equals 1/5 times 2 plus b. So we've got 8 is equal to 2/5 plus b. I'm going to subtract 2/5 from both sides. So let's write 8 as fifths. So this would be 40/5 minus 2/5 is equal to b. Okay, so 40 minus 2 is 38. So this is 38/5 is equal to b. Okay, so let's double check that with our graph. So 38/5 is a little more than 7, because 35/5 would be 7. So this is 7 and 3/5. So that looks pretty good with our graph. Double checking, it's a little more than 7.5 is our y-intercept. Okay, so let's go ahead and write our equation. So we get y is equal to the slope, 1/5, times x, plus the y-intercept, so plus 38/5. Okay, so remember, whenever we write these, we're going to use the improper fraction rather than the mixed number to put into these formulas. In algebra, you really leave mixed numbers behind because they get confusing in equations. Okay, so let's move on to the next exercise. Exercise 3 asks us to determine the equation of the line that goes through these 2 points, -4, 5, and 2, 3. Now, we could plot those, but hopefully you were able to figure out how to find that equation without even having to plot the points, doing what we did with the others. Okay, so we have the points, so we can go straight to the slope. Now, if you haven't tried this yet, remember you want to try it first and then come back and check. So the slope is what? It's the difference in the y's. So 5 minus 3 divided by the difference in the x's, which is negative 4 minus 2. So we end up with 2 over negative 6, which is equal to negative 2/6. You just move that negative sign from the denominator out front. I just like to have it out in front. It really doesn't matter if it's here or here, because the value of the number is the same, but it's much easier to read out here. Okay, we could even simplify this slope to negative 1/3. All right, so we know that any line can be written in the slope-intercept form. Y equals the slope times x, so we have negative 1/3 x plus some number, the y-intercept. Okay, so we're going to go ahead and plug one of our points in, and I'm going to choose this one, I think, 2, negative 3. Or I'm not, sorry, it's not negative 3, 2, 3. And we'll put that in there. So the y-coordinate is 3. And this is going to be negative 1/3 times the x-coordinate, which is 2, plus b. So we've got 3 is equal to negative 2/3 plus b. And I want to get that 2/3 over there, so I'm going to add it. So I get 3 and 2/3 is equal to b. So remember I said I wanted it as an improper fraction, so this would be 11/3 is equal to b. Okay, I'm running out of room, so I'm going to go ahead and write my final equation up here. I'll write it over here. Nope, can't do that. So y is equal to the slope, negative 1/3 x, plus the y-intercept, so it's plus 11/3. All right, so I can't see the graph to check the y-intercept, but I trust the algebra and that it works out. So there's exercise 3. Okay, here's exercise 4. Remember, if you haven't tried it yet, pause and try it before you look at my solution. Okay, so there's the 2 points that I found that would be helpful in finding the slope. And I can draw a little triangle there for my slope, and then also let's record the coordinates of these points. So -6, -2, and then the coordinates of the other point are -7 and +2. Okay, so let's calculate the slope then from those 2 points. So we've got the difference in the y's. We've got 2 minus a -2. And the difference in the x's are -7 minus a -6. Okay, so that becomes 2 minus, I didn't get that negative on there very well. 2 minus negative 2 is the same as 2 plus 2, or 4. And then negative 7 minus a negative 6 is, this becomes plus the opposite, adding the opposite, so that's plus 6. This becomes negative 1 right here. So this whole slope is negative 4, right? And we can see it right here, 1, 2, 3, 4. A drop of 4 for every one horizontal distance. Okay, so our graph can be written using this form of equation. And so we have y is equal to the slope, which is negative 4, times x plus b. So y equals negative 4x plus b. And we're going to put in one of our points for x and y. So we've got, let's go ahead and put in our negative 7, 2 point. So this is negative, whoops, my pen back. Negative 7. And for that y, negative 7, x is backwards, right? You're yelling at me right now. The y, okay. Our y coordinate is the 2. Did I have it right already? The y coordinate is the 2. The x coordinate is the negative 7. I think we got this now. So this is 2 is equal to negative 4 times negative 7 would be positive 28 plus b. So I'm going to subtract 28 from both sides here. So 2 minus 28 is the same as 2 plus a negative 28. So it's going to be negative 26, combining those. Then we've got our 0 there and b. So b is negative 26. So we can write the equation of the line is our slope of negative 4 times x minus 26. It's our answer in slope-intercept form. Okay, so this last problem, I'd like to do a couple ways. So we have a line that goes through the point 8,3 and has a slope of 4, and we're to write the equation that represents the line. So I can do it the exact same way I've been doing these up above. It's just that the slope is done for me. So I can go y is equal to 4x plus b, and then use my point. The y coordinate is 3 is equal to 4 times 8 plus b. So this is 3 is equal to 32 plus b. So I need to subtract 32 from both sides. So let's continue up here. So we've got 3 minus 32 is equal to 32 minus 32, still have plus b there. So 3 minus 32 is the same as 3 plus negative 32, so it's negative 29. And that's our y-intercept. So my equation is y is equal to the slope of 4x minus 29. Okay, I'd like to look at this problem a slightly different way. All right, so let's start with the point 8,3, a slope of 4 like we just did. And I can plug it into this formula directly. So let's see what happens when we do that. We'll put in 4 for the slope, and then we've got x minus x1, which is my x-coordinate of my point, so that's 8, is equal to y minus y1, which is the y-coordinate of my point, or 3. So I've got 4x minus 32 is equal to y minus 3. So I'm going to put this into standard form. So I'm going to subtract y from both sides. Subtract y from both sides. And I get, excuse me, I get on the right-hand side, y minus y is 0, so I'm left with negative 3. Over here, we've got 4x minus y minus 32. All right, so all that's left now is to move the 32 over, add 32, and we get 4x minus y is equal to 32 minus 3, which would be 29. All right, so remember that equation. Let's go back and look at the one we had here. We had y equals 4x minus 29. So let's see if those are equivalent. Y is equal to 4x minus 29. Okay, so it's not quite in standard form. It's actually in slope-intercept form, but we can move it around. So let's go ahead and subtract 4x. Subtract 4x. And I get negative 4x plus y is equal to negative 29. And then what I need to do now is get rid of that negative 4 by multiplying by negative 1. We're going to see if we come up with the same equation here. So negative 1 times negative 4x would be 4x, and then this would be minus y equals 29. Okay, so that's transforming the slope-intercept form that we came up with, and showing that it's equivalent to the one we got using this point slope formula. So you should use whatever you're comfortable with. In this, we're not solving anything. We just need to do a lot of algebra to rearrange things. Okay, but you guys are getting better at this. Okay, let's see what we have here. So the lesson summary you have on your problem set, or near your problem set. It includes this more standard form of the slope formula, which is this one right here. And it just uses different coordinates for the 2 points. Okay, but it's the same idea of the difference in the y over the difference in the x. And we're given this equation here, known as the point-slope form of a linear equation. That's what this is. We already knew the slope-intercept form right here. And it says to write the equation of a line, you must either have 2 points, 1 point and a slope, or if you're given the graph of the line in enough detail, you could find those other things off of it. You could find a point and a slope. So That's what you need to do. So there's lots of different information you might be given and asked to write a line. So take your time on these. Make sure you get the algebra correct. Negative signs are important. And we'll see you back here for lesson 22.